So we are 6 minutes past now. Should we make a start?
Okay, let me introduce Dave. So David Kotz is the Pat and John Rosenwald Professor in the Department of Computer Science at Dartmouth College, and for this academic year until 26 July, a Royal Society Wolfson visiting fellow at Imperial College London, and a visiting professor at UCL. And as a tenured member of the Dartmouth faculty, he has served 15 years in administrative roles as Provost, Associate Dean, and Center Director. And his current research involves security, privacy in smart homes and wireless networks. And that's precisely the talk today, SPLICE, privacy in smart homes. So without further ado, the room is yours.
Thank you, Ignacio. I appreciate it. And thank you for inviting me to the NGN lecture series. Happy to talk about my research today. This is a new talk, or at least the last half of it is new. That hasn't been presented. It's still under submission, but I thought it might be of interest. So as you have guessed from the initial slide there's a set of universities involved in what we call the SPLICE project, Security and Privacy in the Lifecycle of IoT for Consumer Environments. And this is the group of faculty, and we gathered about 7 years ago to create the proposal to the National Science Foundation to fund this work. And they funded it, thankfully, and we have been running for 6 years, almost 6 years, and the project will be coming to a close this fall. We were interested in the advent of smart technologies, smart environments, particularly smart homes. If you think about privacy, one of the most privacy-sensitive spaces where people operate is in their homes. They have a very high expectation of privacy, and yet many of us have been installing smart gadgets in our homes. These are sensing us and our environment and connected to the internet, which could raise some privacy issues. I did a little bit of digging and found some data about the prevalence of these devices in the UK. These figures, I think we have some background conversation that should be muted. Thank you. So the numbers here that I found show that most UK adults have at least one smart device, which is probably a smartphone. But the UK households also, majority have multiple smart devices, in particular a smart TV or a voice assistant, something like that. So this is common and getting more common, and I anticipate homes will start having dozens, if not hundreds, of such devices. So one of the things that I like to do is make sure that I'm clear about the words I'm using. We're talking about smart things or the Internet of Things, and so I went out looking for a definition of the Internet of Things. There is no one definition that I could find. Everybody talks about the IoT and it's never quite clear what they mean. This is what I mean. To me, the IoT is a vision. It's a vision in which everyday objects become smart with the addition of computing and communication capabilities that allows them to talk to each other and perhaps talk to internet services in the cloud. They typically also have some ability to sense their environment or actuate on their environment. So think of a thermometer or a light bulb. And these smart things come in many different shapes and sizes. You know, a typical academic paper will say, well, a smart thing, an IoT device, is small, mobile, battery-powered, resource-constrained. And that's true sometimes, but there are also large, stationary, line-powered, heavily resourced IoT. A refrigerator is in that category, whereas a small, motion sensor that's stuck to a wall might not be, right? Might be more on the other end of the spectrum. So the point is just keep in mind that there's a huge variety. And then a smart environment in this talk is a space, an environment where there are smart things. And they interact with the environment, sensing and actuating on the environment, and with the occupants, either directly through interaction or through sensing and actuating on occupants, and with each other and with internet services. So it's a very rich space of activity. And then, of course, as a computer scientist, I'm interested in cyber threats. People who live in these spaces want their home to be safe by some notion of safety. Obviously, they want to be physically safe. They don't want the smart hob to start fires. And they don't want the smart door lock to unlock at inappropriate times and let adversaries in through the door. So physical harm is a potential concern of a cyber attack as well. If an adversary can break in, compromise a smart device, and perhaps cause physical harm, that's a concern. But also reputational harm. If an adversary causes the release of sensitive personal information to those who should not have it, that could harm the reputation of an occupant. Or financial harm, right? It could cause services to be purchased or money to be used in some way that's not desired, and that could cause financial harm. So that's the kind of threat model that we're thinking about. And when we talk about cybersecurity, we need to think about the adversary. So who is the adversary? Again, in the typical paper, and especially in the trade press, we imagine some guy in his basement who's hacking across the internet to break into your smart home. And that remote third party is certainly a possible adversary. But there are also potentially the thing manufacturer, the vendor who sold the smart device might be adversarial. They might be collecting data from the device and about you and your home, and then sharing it or using it in some way that is inappropriate and violating the privacy of the occupants. Or the owner of the device might be adversarial. So think about a rental flat. So the landlord owns the flat and the thermostat and the refrigerator and the door lock and other devices like that. But then the occupants, the tenants of the flat, are somehow being observed, or their activities observed by these smart devices. The landlord could perhaps, like the manufacturer, be misusing that data and violate the occupant privacy. And then finally, the occupants might be adversarial. So I like to think of a school where you have students, and some of the very clever students might decide to hack into the smart things in the space and perhaps cause trouble, right? And so again, here, the variety of stakeholders and the variety of potential adversaries is important to remember. This is not a simple one-dimensional problem space. And so when we started out, I thought of quite a few research challenges, and I don't have time to go through these today. That's another talk. But there are these challenges, in fact, I think are still unsolved, in the sense that all of these challenges may have a technical solution today, but if it requires a PhD student in computer science to use the solution, it's not a sufficient solution. It needs to be usable by everyday people, grandma and grandpa, who aren't technical and who don't want to be technical, but just want the technology to work. And that is the hard part. So I'm going to talk about two projects today. One of them that's been published and one that's new, that are coming out of my lab in the SPLICE project. And the first one, we were interested in understanding how people think about sharing the data from their smart homes. And this was led by my postdoc at the time, Wei Jia, who is now on faculty at University of Southampton. And she and the team surveyed almost 2,000 people in the United States, asking them a lot of questions and hypothetical scenarios to try to get these answers to these three questions. How do smart home users perceive sharing data from their home with other people, different categories of other people? And how much does that sharing comfort or discomfort depend on the type of data or the type of device? And then given those insights, then what kind of access control mechanisms might be appropriate for enabling those sharing choices? And so here's the overall sense of the results. It's a complicated picture, so let me talk you through it. On the left here, you see this scale from less comfortable to more comfortable, and this represents the average survey respondent here in terms of their degree of comfort in sharing smart home data with some other category of people. So in those categories are these groups here, from landlords to spouses. And this column here is an odds ratio. So it means how much more comfortable is the survey respondent sharing data with that category of person relative to neighbors. And so the landlords, the first one here, is less than one. So people are generally less comfortable sharing with landlords than with neighbors. Not much. I mean, it's 0.99, it's close to 1. But then as we go down to insurance representatives, law enforcement, and guests, people were generally more comfortable sharing with those groups than with neighbors. It kind of makes sense. You want service, you want something from insurance or from law enforcement, you want a service. And so you're willing to maybe share some more data. And with guests, these are people you've invited into your home. You're more likely to have a social relationship with them and be willing to share some data. And this middle group are workers of some kind. They have come to your home to do work for you, and you are more willing to share with them. You have probably a fairly strong trust relationship. And then finally are the co-residents, the other people who live in the home with you, and you have a much stronger trust relationship and more comfortable sharing. So this kind of makes sense. But let me break it down by type of data a little bit. So imagine a security camera. And here we're going to look on a scale of -2 to 2, from less comfortable or uncomfortable to more comfortable. And as you can see, video data, people are not very comfortable sharing. That makes people uncomfortable. Audio data, slightly more comfortable, but still uncomfortable. And then usage history. So for example, how often do you look at the security camera, or for something else, like when do you turn on and off the lights? That was mildly uncomfortable. And the core message, though, here that we found is that the type of data matters more to people than the type of device. So it doesn't matter if it's a security camera or a television or a thermostat. If it's got a camera and it's sharing video data, that's what I care about. Now, if we think about this a little more, what kind of other factors might cause people to become less comfortable? So, for example, if the person to whom I shared the data shares it further to someone else, that makes me uncomfortable, right? That sort of transitive sharing relationship. I might trust Bob, but Bob shares it with Alice, and I didn't have any say in that. Or if it's a non-resident, someone who doesn't reside in the house, doesn't have explicit approval, that makes me less comfortable. Or if one of the data recipients accesses data from a very private space, bathroom, bedroom, something like that. Or if it's a non-resident and who has unlimited access, duration of access, or accesses data about my house from elsewhere, from outside my house, that makes me uncomfortable on average. And so what if we flip that around? What might make people more comfortable? Well, it's kind of the converse of what I just told you. If I give explicit approval, or if the non-residents are inside the home at the time or have a very limited duration of access, or if it's for roommates, they access data from common areas, but not the private areas of a shared flat. It kind of makes sense. So from these and other kinds of insights, we come up with these recommendations. If you're designing a UI that enables people to share data, then it should be simple for new users, but it should have some flexibility so experienced users can express more nuanced options. It should emphasize the data types, not device types, and it should allow describing groups of users, like all the children or all of the roommates or all of the babysitters or what have you. So you don't have to do this on a person-by-person basis. And then on this last one, I think could be a place for agents and AI to to guide the user. So you're thinking about sharing this data. Well, have you thought about this? Have you thought about that? Be careful because of X. And I think a chatbot, for example, could be useful in that mode. So by the way, if you have questions along the way, please just interrupt or raise your hand or something. I'm going to shift now to the second topic. This is the newer work. And here we were interested in the challenge of allowing people to.
I just had one question, if I may, before you go to the second one. So it sounded like, I mean, I don't know how familiar the people that were surveyed were with the different kinds of threat models, right? Because that could then determine whether I'm comfortable sharing or not. So for example, usage history. If I was a thief and I got your usage history and I knew that you were someone who didn't check your camera even though you had it, then I might try and be a bit more bold than if I knew that you were checking every single day and you're really keeping tabs on your things. So that's one example that I could think of from, like, where did the users, the survey respondents know have an explicit threat model in mind, or it was just this is what I feel comfortable as a person, as a human being?
I think it was more the latter. I mean, it would have been difficult, obvious, for us to explain all the possible
Of course,
threat
yeah.
models, and so that's where I think this third or fourth bullet here could be helpful. In other words, because people, unlike us, don't think about these things in the same way, may not recognize the potential risks or benefits to sharing a particular kind of data. Talking them through it might be helpful. And I would imagine potentially AI chatbot could be useful at doing that.
Definitely. Yeah. Thanks.
I have also a related question, which is, I guess, at the end of the day, what was the demographics of the respondents of the survey? And I was wondering up to what extent this reflects their concerns or the ignorance of potential threats. So many people are very happy to use devices, but they have absolutely no idea of the concerns that they bring together, whereas people like us maybe are almost on the opposite extreme, are overconscious and don't want to share absolutely anything just in case.
Yeah, right. So it's the demographics are all in the paper, which by the way was at PETS almost 2 years ago. And they were all US based. We used Prolific to obtain the participants, but otherwise they're fairly diverse. And so some had technical backgrounds, but most did not, I think, as I recall. It was intended to be a more reasonable cross-section of people. And one of the reasons why we had 2,000 participants is we wanted to be able to subdivide it. So the paper breaks it down a little more detailed than I had time for here. But I don't remember offhand, like what percentage of people in each group.
Oh, great. Thank you. That clarifies it.
Okay. Great. So I guess I'll go on to the next topic then. Speaking of LLMs and chatbots, one of the things that we were wondering is, could LLMs help people answer the questions they might have about the privacy issues in some of these smart devices? Does it have a privacy policy? Does it collect image data? Does it share that image data with the vendor? Does it store it for longer than a day? Does it share the data with advertisers? All these kinds of questions that you might have could be perhaps answered by LLMs. We wanted to find out how well can they do that. So the problem is that it's often very hard as a user to easily learn what those answers are. And fortunately, many devices come with a privacy policy document and or a user manual. But of course, they're long, they're full of jargon, and who reads them, right? Almost nobody reads privacy policies. And some researchers have explored the idea of a nutrition label concept, where you boil down the essential points into a very easy to read standardized label, which to my knowledge hasn't really caught on yet. But in any case, it doesn't answer all the kinds of questions you might still have and want to ask. So we looked at some of the prior work, and so some of the work that's similar has focused on mobile apps, privacy issues in apps or websites, and not on IoT. IoT is different, right? It's in the space and it's sensing and actuating on the space. And so it's different than an app or a website. Source documents, other researchers have focused on the privacy policies, but there's often a lot of information in the user manual that may not be in the privacy policy. And that hopefully they're complementary in some way. And so we want to study both. And then the third is that there's a lot of possible questions one could ask, and most other work has crowdsourced those questions, which is a useful thing to do, but it's kind of ad hoc what questions you come up with. We did find a reference that had a list of what we call essential questions. We extracted 115 representative yes/no questions, and they're grouped into 21 categories, and that's what we'll be using for this research. So again, the idea is if you're given the privacy policy and the manual, if you give the LLM the privacy policy and the manual, maybe they can answer the questions, these 115 questions, and how well can they do that? So our core research questions are three. First, how does providing that documentation, the policy or the manual or both, as context to the LLM when asking it a question, How does it affect their ability to answer correctly? And which document works better? Second question, how do these two kinds of documents, privacy policies and manuals, complement each other across the different categories of questions? And if we chose the right document at the right time, according to the question or the category of question, could we get better performance and hopefully close to human annotators' performance? And then third, when the LLM makes mistakes, and trust me, it does, what are the factors that affect it, that seem to affect the LLM's behavior and cause those errors? So as I mentioned, we have 115 yes/no questions. They're sorted into 21 categories. We found 14 devices, common different types of devices on the market, and we've obtained their privacy policy and user manual. And then we experimented with 4 context conditions. So can we feed a question about a device into the LLM and we provide it context? It could be no context, so no documents, or the privacy policy, or the user manual, or both documents, 4 cases. And for each of those combinations, we ran it through 2 pipelines. One is humans and one is AI. And in the human case, we hired some annotators, 2 for each document, and we asked them to try to answer all 115 questions given that document. And the answers have to be yes or no or unknown, because sometimes the document doesn't answer the question. And that became our ground truth. And when we did the same kind of thing, but piping it through LLMs, 10 different LLMs we experimented, then we could compare the LLM outputs with the ground truth and find out how accurate the LLMs are. And we use balanced accuracy because, as you'll see, the distribution of answers is highly imbalanced. So I won't show you all 115 questions, but here's an example of 5 questions. Can a user access the device control or settings or data without a user account? In other words, do you have to have an account in order to access some of those things? Does the device use encryption for data storage? Does it have the capability to collect location data? Does it store data in the cloud? Does it share data with service providers? And so forth. These are the kinds of questions and categories that we were interested in. We used 10 different LLMs from 5 different vendors. These were all the sort of latest models at the time, which was in November when we ran the experiment. And we used 14 different devices. They're a little bit small to see here, but as you can see, there are different kinds: speakers, motion detectors, cameras, door sensors, switches like light switches, door locks. And for each one, then we downloaded the user manual and the privacy policy and extracted them into text, into tokens, so that we could feed them to the LLMs. So as I mentioned, to get the ground truth, we used human annotators, and it was a little tricky, actually. We used 2 annotators for each device document pair. So 14 documents times 2 different kinds of documents. It's 28 combinations. We hired 2 annotators for each combination, and we asked them to go through those 115 questions. And usually the 2 annotators agreed. Sometimes they didn't. And so if they didn't, we had to get an expert, a third annotator, to read more closely and decide which is the appropriate answer. And that gave us the policy ground truth and the manual ground truth. And then we, from that, derived what we call the combined ground truth. If you had read both manual and policy, nobody did, but if you had, what would be your answer? And that's, of course, if the 2 agree, that's the answer. If one is yes and the other's unknown, the answer is yes. The answer's no and unknown, the answer is no. But if one says yes and one says no, which is very rare, we had, again, an expert had to decide what's the ground truth. So we ended up with 1,600 labels here. And unlike some old, traditional machine learning, we're not using these labels for training a model. This is just our ground truth against which we're going to compare the LLM output. So for the LLMs, again, we have all these possible combinations. 115 questions times 14 devices times 4 different kinds of contexts that could be fed in. And we feed them into one of 10 LLMs. We repeat each 3 times and take a majority vote of the LLM's output, because, as you know, they are randomized. somewhat, and so they sometimes will produce different answers. And we asked the LM explicitly to say yes, no, or unknown. It was told to make one of three outputs. And one thing I thought was interesting was that the ground truth, even, and I'll get to the LLMs in a minute, was highly unbalanced. So notice the number of unknown answers here. There's a very large fraction of the questions for some of the devices were not answerable with either document. That would be this corner down here. 52% of the question device pairs were not answerable. And then more of them were yes or no. And to me, this shows a failing of the documents that they don't have that information. This is a breakdown of that. It's kind of a busy diagram, but across the bottom here are the categories, so 21 different categories of questions, because some questions were more likely answerable than others. And what you see in the gray is when neither document has the answer. So those are the cases where the question simply wasn't answerable given the information in the documents. And then the orange are where they both have an answer and it's the same answer. That's good. And the black is where they both have an answer, but it's different. That's bad. Fortunately, it was very rare. And then blue is a case where one or the other had an answer to the question. And it gives you just a sense of the kind of variety of the situation here. So let's dive in and take a look at the results. Or really the findings we're deriving from the results. So this one is showing across the bottom 4 different context combinations. So just the policy provided as context, or just the manual, or both were provided, or neither was provided. And this is balanced accuracy on the y-axis. And in each graph, you'll see 10 box plots, each representing a different LLM. And sort of if you're standing way back, the first thing you notice is that when you don't give it any documentation, it does worse. Okay, that makes sense. If there's no information, it's kind of hard to answer the questions. But what was also interesting is that the policy only was best, better than having just the manual. But interestingly, if you give it both the policy and the manual, it does worse than either one. And that was kind of our next finding, was that the combined context was not better. And we think that may be because having too much information kind of confused the LLM. I know that's an informal statement, but it seemed to cause it to get lost and not be able to find the correct answer as well as it could if it had only one or the other. So this is comparing the different possible groups here. This, what this delta median means is that the median of, in this first case, the median of the accuracies for policy only was 0.1 better than the median of accuracies for the manual only. And that was a statistically significant difference. So the policy was better than manual only, better than combined, better than no context. That's what this says. However, I thought this is also really interesting. So sometimes, as I've said, there is no answer in the document, in either document. And if you give it no context at all, no document, sometimes it's wrong and it says yes or no. It should say unknown, right? Because the information is not in the document. But if it says yes or no, that's wrong. And it's sort of guessing, in effect. Or if you give it a document, there's no information in the document to answer this question, but you give it one of the documents, it's more often saying unknown, which is kind of interesting. It's kind of grounding the LLM from making a guess or from making a mistaken guess and just saying, well, okay, you gave me the privacy policy, you asked me a question, I don't see an answer, it's unknown, which is correct in this case. 9 out of 10 LLMs improved when given a document, either one, when there was no information in the document. So I just thought that was a curious result. There was no best document in every case. So for some categories, the manual was significantly better. So again, here, delta median here means the the difference in balanced accuracy between the median accuracy with the manual versus with the policy. And a negative one here is a case where the manual was worse, and therefore the policy was better. So for some categories of questions, it's better to provide the policy as context. For other categories of questions, it's better to provide the manual as context. And some of this kind of makes sense. You know, if you're asking about the types of sensors, it's probably more in the manual. If you're asking about standards compliance, legal issues, it's more likely in the policy. And so that led us to think, well, if giving both documents is making it worse, maybe what we should do is, depending on the category of question, well, let's give it the one or the other according to this table, or a table like this. So when we do that, if we given a particular question, you figure out which category is that question, and then you look up this previous result, what is the best document type for that category, and then query with that one. Maybe LLMs will have better accuracy. And there are different ways you could do this step, like how do you know which is the best document for the category? One way is what my student calls leave one device out. So we had 14 devices. You take the other 13 devices and build a model, essentially, of which policy or manual was better when LLMs are trying to answer questions about that category. And then when faced with a question about the held out device, use that pick. And that helped. It reduced the gap between LLM's accuracy and humans' accuracy from 12.8% to 8.5%. So the LLMs got better, closer, not quite as good as humans. And then the other approach is don't leave any devices out. Just train on all 14 devices, because in the future, you're going to be asking questions about one of the 14 devices. No harm, in my view, in training on all of them. And this improved it from 13 to 4.4%. So we got very close now to human accuracy by using this approach. And here is one of the final findings. It's kind of another curiosity. We use GPT-5 and GPT-5 Mini as two of the LLMs. And my student noticed that GPT-5, even though it's a bigger model than GPT-5 Mini by definition, often did worse. And he was curious, well, why is that? It seems like GPT-5 Mini should always be at least as good as GPT-5 should be at least as good as GPT-5 Mini. So here's we've broken it down to the different kinds of context you might provide and whether they were both correct or both wrong. And you would like to think that both LLMs behave the same way. They're either both going to get it right or they're both going to get it wrong. And that was true most of the time. But there were cases where only GPT-5 got it right, and there were cases where only GPT-5 Mini got it right. In fact, more cases like that than like that, which is surprising. I would have expected, okay, this is a bigger model. Sometimes it's going to get it right, and the Mini model's not. But to see this numbers much larger was a surprise. And so we were trying to figure out why that is. Of course, as with LLMs, it's never quite clear exactly why they do what they do. But even though GPT-5 was using more tokens, we measured that, it just didn't get more accuracy. So one hypothesis was that LLMs were relying on their pre-trained parametric knowledge and not the document. So the provision of the document didn't really matter that much, but maybe it's just something about their pre-training. Well, this was a very small number of failures that were related to that. We asked them, show us the evidence for yes or for no, and they were able to find it, or not in the case of the failures. And so that didn't explain it. Maybe they couldn't find the right place, the right information to answer the question. But again, by probing, it seems that they could most of the time. So our conclusion, or the best hypothesis at this point, is that they just simply read the passage differently than humans. So there's a lot of cases. You saw the number here is a very large number of cases, but my student went back and manually inspected 120 failure cases. He read the manual or the privacy policy, and he looked at what the LLM was saying, and he could imagine where an LLM would interpret the passage differently than what a human did. So to summarize these results, 2 slides. First one is some design implications. So if you were going to build such a Q&A assistant, which seems like it might be useful, his first suggestion is, use a structured retrieval method that preserves the provenance. So did it come from the privacy policy or from the manual? And enforce the model or the agent to abstain, meaning say unknown when you don't know. We did that explicitly through the way we queried the model, is to say, here's a question about this device, here's the context, you must answer yes, no, or unknown. Something like that we thought was important. To post-train for expert aligned interpretation. So sometimes the policy text or the manual is ambiguous, and you need to do some post-training of the model to incorporate expert interpretation of the text. And then finally is actually not technical, really. It's to push the vendors and standards bodies to be more clear in their documentation and to be more complete, to actually try to answer more of these questions. In fact, if you just had an FAQ for all those 115 essential questions, you'd go a long way. In principle, then an LLM would be perfect on those questions and presumably be better able to answer related questions as well. So 4 takeaway messages. The context documents were critical. The meaning and accuracy with no context was only 47%. But when you give the privacy policy, we got up to 74% on median. Privacy policies and user manuals were complementary. They were different, and so it is useful to have access to both. But as we saw, by providing both at the same time, that led the LLMs, some of them, to perform worse. And so providing the appropriate document was most helpful. This interpretation misalignment seemed to be the reason for the errors, although it is, as I said, hard to know why LLMs do what they do. And the sort of bottom line is that at least these LLMs at that time were not quite as accurate as humans. We were able to get close by choosing the right document, 4% less than humans, but more work is needed, and maybe the newer LLMs will get even closer. So with that, I'm happy to talk more about those, answer questions. If you're interested in SPLICE the whole, check out our website, spliceproject.org, which is also at the bottom of this slide. Thank you.
Thank you. That was fascinating. I had one question while others are thinking further. So that's very interesting that LLMs are kind of interpreting English in a different way than human beings are. Is that because these are technical manuals and they're not sort of trained on that, or do you have one or two examples that could tell us like why this might be happening? It's very hard, as you say, with LLMs, why they do what they do.
Yeah, no, it's a good question. I should have an example. Sorry, I do not. I should have. That's a great tip. I'll add it to the next version of these slides. I don't think it's because they're not trained on these documents. I mean, these are publicly available documents on the web. We didn't even buy these devices. You didn't need to. We just downloaded. So they presumably have been trained, in fact, on these documents, probably. And that's how we were able to answer any questions with no context, is that if you ask about a Samsung 2952 TV, it has some knowledge about that from just its pre-training. I suspect that some of it is just the ambiguity of English, and the LLMs happen to interpret it differently than our humans. As I noted, we had cases where the 2 human annotators disagreed, and the expert third annotator had to come in and resolve that. So sometimes it's just not clear.
Right. Yeah, that makes sense. The other thing I was thinking.
Sorry. Please go ahead, Lisa.
The other thing I was kind of thinking was that maybe other than LLMs, there are LLM adjacent models like Notebook LM from Google, for example, which you give it a bunch of PDFs and then you can ask it questions about those PDFs, and it kind of grounds its answers in the context you've given it. I wonder, because you have the exact context, the manual and the privacy policy, if Notebook LM might do slightly better than larger models. Like, I mean, the other fascinating thing was that Mini was doing better than the bigger GPT-5. So
Yeah.
yeah.
That's a good point. The Notebook LM and things like that are designed for that purpose, and they may do better than these general LLMs, even when given the PDFs. We should try that out.
Sorry, Ignacio, you had a question.
My questions were actually related to yours. I was also wondering up to what extent this is specific to this use case, or you could pretty much find almost the same if you were to do a similar analysis on something else completely different. So is just the ability of the model to reason, or is about the ability to understand the background context to be able to reason? So if you were to do this with vacuum cleaners, say, could it be the same, do you think, or do you think that it's a matter of the context that is more specific, more complex to get?
I, of course, have no data to answer that question, but I would say it feels like it would be simpler for devices like vacuum cleaners. Hopefully, I don't know if they're internet connected vacuum cleaners. I guess they're the robots, right? But the ones that are not so electronic, that are more analog, I would assume is probably better at, probably in part because those devices are simpler by nature and also more traditional, and the sort of core knowledge might be sufficient. But that's really just a guess. A couple of other thoughts. We extracted the text from the manuals and the privacy policy, but sometimes there's information in diagrams, and we were not using the diagrams, right? And so tables, we tried to preserve tables from the documents by converting everything to Markdown, but it's tricky to retain that information in the context. So it may be, if we use newer models and we try to preserve the full text, the PDF and all of its imagery, it might help. The other thing we did was to extract only the English section. And it would be interesting, some manuals come with like 3, 5, 10 languages, right? Maybe throwing in all that would allow it to somehow get information out better by reading all 10 languages.
You have preempted one of my questions, because I was going to ask you if in the cases where you had multiple languages, somehow it managed to triangulate between them and get a better understanding.
It would be really interesting to see if the answer differed between languages.
Would you try to somehow get a grasp on how complete or clear the document is, like some sort of rankings that you could somehow normalize by it? This policy is very complete and very detailed and very well expressed. This one is all over the place. Half of the things that should be there are not there, and therefore these two things are really hard to compare. We are comparing more the quality of the documents than the ability of the model.
Yeah, that's a good point. As I mentioned, there are a lot of questions that were not answerable. This is just an aggregate here, of course, across all devices. But even the privacy policy, which you would hope would have answers to privacy-related questions, was unable to answer 62% of questions across all questions and device pairs. And that's our ground truth. I mean, the humans couldn't find the answer either. Some might say that some of the questions are obvious, like, does it have Wi-Fi? No, like, does it have a camera? Earbuds probably don't have a camera. Although, by the way, I've seen speculation that Apple is adding cameras to the next generation of AirPods. It's another story. So no, I don't have the answer to your question, but it would be interesting to see the distribution of quality of the documents.
Angelina,
I think you had a question.
Yes. Hi. Thanks so much for the presentation. I'm a PhD student at UCL looking at cyber physical systems and machine learning. I was just wondering how you're thinking about the future in terms of this work and how models are becoming increasingly capable. I know, various labs are working on context management, larger context windows, and if you think that would have an effect, or sort of related to the question we were just discussing, does it maybe come down to the quality of the data or anything else?
It's probably a both and. I think context windows probably did play a role here, especially when we gave it both documents. It seemed to be, like at least the symptom was that it reduced the accuracy relative to providing only one or the other. And that may be because they weren't able to fully use the context that we provided. I think newer models will definitely be better, right? And or one could argue we should redo this in in November. It's a lot of work. I'm not going to do it again. Where we're going next with this, we're really interested in whether. So this would be the design of a Q&A agent, an agent you could talk to or chat with through some medium, just to ask these questions. We only explored yes/no questions. It would be interesting to look at more open-ended questions, and we're interested in to what extent an agent could help you recognize to someone's earlier question what you as a person should be thinking about. Like, you're asking me this question about privacy, but have you thought about this? Did you know that this device has that? I think that would be obviously raise it up a whole level in terms of its capability and usefulness. And that could be a really good direction to go.
Amazing, kind of an answer to some of the challenges you were speaking about with the first paper.
Exactly. Yeah.
Thank you.
Any other questions? Maybe one more from my side while other people maybe think about other questions. So you were saying about having something like an FIQ checklist. That sounds like a pretty good idea. Like devices, there should be some sort of checklist of what devices need to comply to or provide an answer to. Have you discussed this with anyone on policy areas? Is there any thinking about doing something similar to that?
I have not, but the closest thing to that I'm aware of, let me see if I can pull this back up. No. Sorry, there we go. So there has been a lot of work on this concept of nutrition labels, which is similar. It's an effort to literally put on the box of a device that you might buy, standardized format, high level description of this one. I can't read it fully, but it has video and audio, and it does not have physiological sensing, things like that. And then a QR code, so you could go to a more detailed online version of that as well. And so those efforts, which I believe have been pushed by NIST, the U.S. National Institute of Standards and Technology. I think they're actually trying to develop some new regulations in this direction. If that happens, it would be a good thing. It wouldn't be as complete as maybe the full FAQ we have in mind, but standardizing the kinds of information that people need would be a big win.
Absolutely. Thank you.
You could even maybe just do it in a crowdsourced manner, right? If I search for manuals for my home devices, I can find the manuals online all the time. What you're saying is like, if these 115 questions were answered, and maybe from there distill it down to a NIST nutrition label like thing.
Yeah, that's a good idea. I mean, right now, if you do a Google search, you'll get stuff from the manufacturer, but you also get Reddit and Amazon question and answers. Other places where real users have contributed their information.
Mm-hmm. Yeah, very cool stuff. Any other questions from anyone? Not? Thanks, Dave. That was fantastic.
Yeah, thank you.
We'll see you in person before you leave back for the US.
I hope so. That'd be great. Thanks all. Have a good weekend.
Bye.